In this example, let's solve another problem by induction. So proof by mathematical induction. Let's start with the base case. So the base case will have a P of 1 should be true, and that is this first element here. 1 factorial is it equals to n plus 1 factorial minus 1, where n is equals to 1. So 1 factorial will be 1 times 1, and this will be 1 plus 2, or 1 plus 1. Factorial minus 1. So that this will be 2 factorial 2 minus 1 is equals to 1, and you have 1 equals to 1. So therefore the base case holds to be true. Next will be the inductive case. So in this case, let's assume pk is true. And in that case, this will be 1 up to k, and this should be true, meaning that you will have k plus 1 factorial minus 1. Given that assumption, let's show that it should follow to the next element. So pk plus 1 should also be true. So therefore we are going to prove 1 factorial plus 2 up to k, and the next element k plus 1. So k plus 1 factorial should be equals to k plus 1 plus 1 factorial minus 1. And the usual drill will be to substitute the assumption, this one, which is equivalent to the first group, and the substitution could be this one, k plus 1 factorial minus 1 can be substituted to this, because by assumption they are equal. So by assumption we have k plus 1 factorial minus 1, so plus k plus 1 factorial, and this should be equivalent to k plus 2 factorial minus 1, and they can be shown to be equivalent by simple algebra manipulation. So let's just clear some space here. So by factoring out k plus 1, so let me rearrange this one first. Rearranging, I will have, say, k plus 1 k plus 1 factorial plus k plus 1 factorial. I did not do any manipulation yet, just rearranging the terms, is equals to k plus 1 or k plus 2 factorial minus 1. So we can notice that this is easily factorable. Say k plus 1 factorial and k plus 1 factorial. We will have this one as k plus 1 and what is left will be k plus 1 factorial. So k plus 1, this term, so k plus 1, and the leftover from this term will be another 1, so minus 1 is equals to k plus 2 factorial minus 1. And this will be equivalent to k plus 2, and basically k plus 2 times k plus 1 factorial, this one, k plus 1 factorial times k plus 2 will amount to k plus 2 factorial. So this will be k plus 2 factorial minus 1, thus equal to the right hand side, k plus 2 factorial minus 1. And that's it.